Welcome to Ask and Learn.
Hello student, in this problem, a parallel combination of inductance and resistance is given. Okay, so here an inductor L and a resistor R is connected. Okay, and it is desired to have connect a capacitor C in series with this circuit so that our net impedance of the circuit will be resistive, and it is at the frequency of 10 megahertz. Okay, frequency of 10 megahertz. Okay, and the value of inductor is 20 microhenry and the resistor is 300 ohm, and the resistor, the value of capacitor is C. So we have to find out the value of capacitor for the circuit will be purely resistive at the frequency of 10 megahertz. Okay, so now first we have to calculate the total impedance of the circuit, Z input. Okay, so Z input will be here the resistor and the inductor are connected in parallel. Both are connected in parallel in series with the capacitor C. So the net impedance, the net input impedance is 1 upon j omega C plus R parallel j omega L. Okay, so Z input equals to 1 upon j omega C plus by calculating the parallel combination, it give j omega R L upon R plus j omega L. Okay, so now Z input equals to, by taking iota in numerator term, minus iota upon omega C plus by multiplying the complex conjugate in this term, it give j omega R L multiply R minus iota omega L upon, it give R square plus omega square L square. So now Z input equals to minus j upon omega C plus by multiply this function j omega R square j omega R square L and here minus sign and iota into iota square is also minus 1. So we put plus omega square L square R upon R square plus omega square L square, equation number first. Okay, so now here we apply the impedance concept. Okay, so in impedance concept, in this circuit the net impedance will be resistive whenever we connect our capacitor. So in that condition, the imaginary component of Z input equals to 0 when circuit will be resistive. Okay, circuit will be resistive. So we put the imaginary component in this function will be 0. Okay, so in this, here this is imaginary function and here this is our imaginary function. Okay, omega R square L upon R square plus omega square L. Okay, so here minus 1 upon omega C plus omega R square L upon R square plus omega square L square put equals to 0. Okay, now by calculating this value, 1 upon omega C equals to omega R square L upon R square plus omega square L square if we solve this function for the value of capacitor, then our capacitor C will be R square plus omega square L square upon omega square L R square. Okay, so this is the value of capacitor. Okay, this is the value of capacitor, and we know that the frequency will be 10 megahertz. Okay, or frequency will be 10 megahertz. F equals to 10 megahertz. Okay, so F equals to 10 into 10 ki power 6, it gives 10 ki power 7. Now we have to calculate the value of capacitor. So we put the value of resistors R, it is 300, inductor L, it is 20 microhenry. Okay, 20 microhenry. So C will be C equals to R square plus, what about the omega? Omega is 2 pi f. It is 2 pi f whole square multiplied by L square upon omega means 2 pi f whole square into L into R square. So now we put the value C equals to, what about the R? R is 300. So it is 300 square plus 2 pi into 10 ki power 7 whole square into, what about the L? L is 20 microhenry. So it is 20 into 10 ki power minus 6. 20 into 10 ki power minus 6 whole square upon again 2 pi into 10 ki power 7 whole square multiply by inductor L 20 into 10 ki power minus 6 into R square, it is 300 whole square. Okay, so now we have to solve this function, and it is give, so this give 2.3488 into 10 ki power minus 10 farad, or we can convert this value C equals to 234, or we can write it 235 picofarad. It is clear? 235 picofarad. In this problem, first we calculate the total impedance of the circuit and apply the concept for the circuit will be purely resistive. The imaginary component will be 0, and find the value of capacitor C, and by putting the value of all these parameters we can easily calculate the value of capacitor C, which is 235 picofarad. It is clear? Thank you.